Hello everyone, my name is Mark Baggett. Welcome to KringleCon and my talk on escaping Python shells. First, I'd like to thank Santa Claus for inviting me here to talk. I have always dreamed of speaking at KringleCon, and has this been an amazing conference just to go around and see all the things? With that, I know all of you have many other things you could be doing here at this conference. There's a lot of things going on. So let me just jump right into the material. If you guys wouldn't mind, here in the front, balloon heads, if you wouldn't mind pulling down your balloon just a little bit so the people behind you can see. I appreciate that very much. All right, so my name is Mark Baggett. I am a senior instructor for SANS. I'm also the author of SEC 573, which is Automating Information Security with Python. There we talk about developing tools in Python, how to apply Python development skills to forensics, to defense, and to incident response. I've got my master's degree in information security, got my GSE, and I've been doing this for a while. So if you would like to follow along with me during the presentation, I've got a couple of URLs you can go to. You can go to tinyurl.com/Python secrets. There you will find some code samples that you'll see me using throughout today's presentation. Also, you can go directly to it if you don't trust tinyurls at gists.github.com/Mark Baggett. There you'll see several presentations that I've done. This one's called Python Sinister Secrets. And if you click on that, you'll find, once again, that same code that you can go directly to with tinyurl. So I'm talking to you today about how to escape from restricted Python shells. And there's a couple of different techniques that, well, systems administrators will take in order to try and create a Python environment where you can go in and they can use these environments for education, for teaching you how to do things in Python, but they don't want you to have full control of the system. And as you'll see here, it's almost impossible to create a Python shell that gives you the interactivity that you need to be able to really experience Python without also giving you the ability to access the underlying system. So I'm going to talk about a couple of techniques and how we can get around those. So one technique that systems administrators will use is to override the modules that are in memory on a system with other functions. So in this case, I'm importing the sys module. Sys is where you would go to get access to the modules that are built in to Python and loaded in memory by the Python interpreter. So inside this sys module, I'm going to then go into modules.os.systems, and I'm going to overwrite the system function in there with a function that just prints stop hacking. And I'll do the same thing for the popen function here, where I'm going to overwrite that with a function that just says stop hacking. Then once I've overwritten those functions in memory, I can delete the system module. And then if at some point later in time you come and you import the OS module, and then you do something like os.system, trying to execute that system function inside the OS module, you don't actually get to call os.system. Instead, what you get is executing my little function up here that just prints stop hacking. So this is one technique that some systems administrators will use to create a restricted Python shell, but this is futile. If someone can load modules, import modules, then they can also reload modules. So in Python 3, there is a module called importlib. And if you call importlib.reload, you can tell it to reload specific modules. So for example, I can tell it to reload the OS module from disk, at which point it reaches out to the hard drive and it reloads that module, overwriting the nasty function that I put in memory, so that now you can call os.system and then run a function such as ID, and it no longer executes that my function that's no longer in memory. Now the valid code is back in memory. So if someone is overwriting functions in memory, then simply reloading the module will allow you to get back the original functionality. Another way that systems administrators will try and create a restricted Python shell is they'll have Python launch a child process, and then they'll filter the input in the parent process and then pass that down to the child process. So for example, here, you don't really have to understand everything that's going on here, but I import read lines, which is going to give me access to the command line, reading things as they're being typed on the keyboard. And I import code. Code is going to allow me to execute down here where I call code.interact a new shell. And in this shell, I want the read function for this shell to be equal to this thing I've called read filter. And if we come up here and look in read filter, I can see that I'll use the input function to collect things on the keyboard. And then I'm just going to check to see if whatever is typed on the command line or in the Python shell includes the words import, eval, exec, or compile. Those 4 keywords are notoriously dangerous and usually tightly controlled if someone's trying to create a restricted Python environment. Because with these things, well, import, as we saw earlier, can be used to load modules. Eval can be used to pass it a script in the form of a string, and it'll execute that script. Exec can as well, and compile will take a script and turn it into bytecode. We're going to look at each of these. So this is one way that people will do this, and this is almost effective, which means it's 100% not effective. It doesn't work. And we'll look at a couple of different ways we could get around that. So if someone has, for example, if someone has restricted the exec function, right? They don't allow you to run exec. Well, so for example, here I'm in a restricted shell and I just type import OS. Well, the import command is forbidden. Okay? And in this example, the exec command can still be used. So what I can do is I can say exec, and then I could build a string that says import OS. Now, if my string simply said import OS, then that filter that's looking to see does my line contain the word import anywhere would block it. So I'll break my import statement into 2 strings. So my first string says IMP, and then I'll add ORT space OS, which becomes import OS. So then when I exec that string, it imports the OS module, and now I can run os.system and run the ID function there. Now exec, you'll see, takes a straight string of Python code and it'll execute it. It expects that this string is going to be a series of Python keywords and not a call to a function that exists in Python. Eval is another dangerous command that is often controlled. What eval does is it works just like exec, but instead of having just a straight up Python command that's being passed to eval, it is expecting you to give a Python function or a call to a Python function. It's expecting that whatever's inside of the string that you pass it is going to have a return value. So here we try to import the OS module. It doesn't allow us to do that. So another way I could import OS is I could call the import function and pass it OS. So underscore underscore import underscore underscore is a function version of the import command. So here I'm going to try and call the import function and import OS. And again, you can see the command is forbidden. Why? Well, because import, the letters IMPORT are on my line, and that's being filtered by that input filter. But I can take this and break it down into 2 strings. So if I just take this line here, put it in between my quotes as IM, and then add PORT underscore underscore OS, then now instead of using exec, I'm going to call eval, because this is a function and not a statement. I'm going to call eval. This is going to execute that function and return back to me the operating system or the OS that was called. It's going to load that module into this variable named OS. So now I can call os.system and execute functions within it. Okay. Compile is another one that is often restricted, but I'm going to show these to you in the form of a demonstration. So I'm going to come over here to a Python shell, and let's just, let me actually get out of this, and let's cat my restricted shell.py. Here you can see I've got my read filter, and this is going to filter out whatever's in the blacklist. And I'm actually going to run this 4 different times with 4 different restrictions. The first time, I'm going to have a blacklist that blocks import, eval, and compile. The second time, I'm going to block import, eval, or import exec and compile. And the last time I'm going to blacklist import, exec, and eval. And then this very last time I'm going to block all 4 of the dangerous commands and see what we can do there. All right, so let's run this thing here. So I'm going to say Python 3 restricted shell, and it comes up with my restricted shell. So if I type import or exec, I can see that it tells me that's a built-in function, which means that it works. If I try eval, I can see that that's forbidden. I can try compile. I can see that one is forbidden. So the only one that's not forbidden here is exec. So I want to import the OS module and then run call os.system to execute a command on the remote system. So I'm going to, let's do this. If I tried to just say import OS, right, it doesn't like that. Let's put it inside of quotes though, and pass that to exec. And it still doesn't like that because it still contains my string. So let's break up the string, and it seemed to have worked. So now I can call os.system, and I can give it a command that I want to run, such as the id command or the ls command, or the ks command, which does nothing. How about the ls command? All right, typing is hard. Close quote, close parentheses. There you go. So that runs the ls command. All right, so in this case, exec was allowed. Let me hit Control D to get out of that. And now I'm in a new restricted shell. So let's see what commands work here. I'm going to try import. Doesn't work. Exec. Doesn't work. Eval works. Compile doesn't work. But eval works. So in this case, eval wants a function. So I could try and call the function version of import and see what happens here. That's again forbidden. Let's break that down into a string. Let's put this into a module called OS, and I need to break that string somewhere. So I don't have the word import in my string. And now I can call os.system and give it a command such as id. Okay. So if the eval function is blocked, then we can use this syntax to get around that and execute code. All right, let's hit Control D, try our next restricted shell. All right, so what do we have here? Let's try import. Nope. Let's try exec, eval. All of those are blocked, but compile is still allowed. So what does compile do? Well, compile takes a string and it turns it into bytecode. So what I could do is do something like this. I could say code equals compile. Let's just say import. Well, let's see, I'm going to have to break this up. Im plus quote port OS. Okay, so it's also going to take a second parameter, which is a blank string, and then a third parameter, which is the word single. It says compile that single line into bytecode. Okay, so now code, if I look at it, well, it contains a Python code object. Now you can't just run this. I need to find a way to execute it. So what I can do is I can create a function. Here I'm just going to create a function called a that does nothing. And then I'm going to say a dot underscore code is equal to my code variable, overwriting the existing code on that function. Now when I run a, hopefully that imported OS. So let's try os.system ID. You can see that in fact it did import my OS module, and I was still able to execute code. All right, so that's what you can do if import, exec, and compile are blocked. Let's try one last one, and that is what happens if execute the id command code. Let's see here. Let me try that again. Shell 1, shell 2, shell 3. All right, let's try this last restricted shell here. Import is blocked. Exec is blocked. eval is blocked, compile is blocked. So how can I get around here? Well, in this restricted shell, I can't use any of the tricks that I've used before, but what I can do is I can go back to a different machine, a machine that I control. For example, here is here is a different computer, one that's controlled by the attacker. Sorry. So here I'm going to type Python 3, and then I'm going to put into Python 3 a little module that I've created called makeObject. Okay, and you can grab a copy of makeObject from my GitHub. What makeObject does is it turns a Python function that's in memory into a string. So here I can create a function. Let's just call this def bypass. Doesn't take in any arguments. And in here, what bypass is going to do is it's going to import OS. It's going to print boom to the screen. And then I'm going to print the results of calling os.system and passing it the ID command. Okay. So now I've got my function called bypass. I would like to take it out of memory on this Python system and move it to the other system. So first, let me paste my getObject function into this. And then I'm going to call getObject, or makeObject, excuse me. And I'm going to pass that my function called bypass. And when I do, it creates this string that I can just copy and paste into the remote system. Okay, so let's do that. Let's just take this and copy it. I'll come back over here. And none of those commands, none of the previous commands worked. So let me paste this in here. And so this created a function called A, and then it used some typecasting to create a new code object, passing in all of the objects. And here you can see these are passed in as bytecodes. Now, all the functions in here, such as OS and system and others, are passed in as strings, which means if I needed to break these things up, for example, if system was blocked, well, I could just change that to sys plus stem, and that would work just fine. So now what happens when I run my A function? You can see that boom is printed, it imported my OS module, and then still executed the code. So depending upon how they are attempting to secure the Python terminal, there's almost always a way to bypass it. And it gets even worse than this, because built into Python itself, there are modules and functions that already exist inside of every Python program, such that there's always a way for the attackers to run code inside those Python windows. As a matter of fact, impossible is never a word we should use in information security, but I dare say that it is extremely difficult to ever build an interactive Python program or interactive Python shell that can restrict a user completely and keep them from executing things on the operating system, short of building a custom interpreter from scratch. Well, that's all I have for you. Thank you for coming out to my talk here at KringleCon. Enjoy the rest of your month here at KringleCon, and have a great day.